Welcome to our first PowerPoint for our Properties of Water unit. Today we start with solids, liquids, and gases. By the end of this PowerPoint, we should be able to answer the question, what changes occur in particle motion, temperature, and state of a pure substance when thermal or heat energy is added or removed? We know there are three phases: solid, liquid, and gas, also known as states of matter or phases. And we also know that we can use these descriptors to describe the physical property of a particular object. When it comes to how these particles move, we know that they will vibrate against each other, they will slide in a fluid movement, or they will zoom around in the space. All matter is made of tiny particles. We know this already. And those particles are in constant motion. How tightly packed these particles are determine how they move. Particles will vibrate or move more if the matter is heated. So think about if you have a boiling pot of water and we continue to add heat to it and that water begins to evaporate, those particles are going to move around a lot faster as a gas than they are as a liquid. And particles will vibrate or move around less if matter is cooled. So if we take that evaporated gas and we cool it or we condense it back to a liquid, it's going to slow those particles down. And if we continue to cool the liquid until it's frozen into a solid ice cube, it's going to continue to slow that movement down to the point where those particles are just vibrating against each other. So starting with our solids. Solids have a definite shape and a definite volume. You can see in our picture down here, those particles are tightly packed. There is motion there. It's just the slight vibration of the particles up against each other. And we know that shape is not going to change. The car is the car. The bucket is a bucket. That does not change. Liquids have a little more freedom. They have a definite volume, but not a definite shape. We know that liquids will take on the shape of the container that we put it in. So, for instance, in our pictures over here, we have a liquid in this glass, so the liquid takes the shape of that glass. Or down here, you have the gasoline pump. The liquid is going to come out in a stream because that is the shape of the last place the liquid has come from. Or this instance here with the dropper, it's going to take the shape of a drop of water because that's the shape of the container that it's coming from. Liquids, the particles are still pretty tightly packed, but there is enough room in between them now that they do slide over one another. That's what gives liquid its fluid motion, that motion of pouring from a bottle to a glass. Gases, no definite volume, no definite shape. It all depends on the container. Gases will take on the shape of their container. And remember from our previous discussion about solid, liquid, gas, almost anything that can enclose space is going to be a container. We use the example of if we are in a classroom, the door and the windows are shut, and we spray air freshener on the corner of the room, eventually the gas particles from that spray are going to spread and fill the space of the room. So it's not just the corner that smells like the air freshener. Eventually the whole room does. These particles, unlike liquid or solid, are very far apart and they move freely, except for when they collide. Or if you were in my class, we call that bump and fly. They knock into each other and they fly off in different directions. We also know that by adding or removing thermal or heat energy, we can change our matter from one state to another, and each can become the other state. This is just a quick chart. If we're moving from the liquid to the gas, we are adding heat. So that's going to create boiling, which leads to evaporation. And that means that heat is going into the liquid as it evaporates into a gas. The next one down is going to be gas to a liquid. So now we're going the other way. We are removing heat from the gas, and we call that condensation. And when heat leaves the gas, all those particles condense and they move closer together until they become liquid. And in our last phase change, we're going from solid to a liquid. When we're going from solid to a liquid, we are applying heat, and we call that melting. And heat goes into that solid as it is melting. The opposite of that is not on the chart is the liquid to a solid. When we're moving from liquid to solid, we are taking heat away, and that object is now freezing. I want to spend some time here looking at this diagram. It's very important that when you move through 7th and then 8th grade science, that you gain the skills of really understanding how to read charts and diagrams and tables. Your SOL has lots of questions related to being able to pull information off of charts and tables and diagrams. What we're looking at in this chart is all of our phase changes, whether we are adding heat or we are taking heat away. The first thing I want to point out are our x-axis, which is labeled down here as our heat energy, and it is moving, the arrow is moving in this direction, meaning as we move down the chart or the graph, heat is being added. And on our y is temperature. And as we move up, it's getting hotter. So let's start down here in the corner with a solid. Solid of the 3 phase changes is going to have the least amount of heat. When we add heat to a solid, we get melting. So here we have the picture of the ice cube, and the ice cube is beginning to melt into a liquid. So now our ice cube has become the glass of water, and it is a liquid. As we continue to add heat by turning the temperature up, that heat begins to vaporize or evaporate our liquid into a gas. And we see that pictured here with the tea kettle. It is the gas or the water vapor that you see that looks like smoke. What the 3 of these have in common is that more heat is being added because the temperature is going up. Also why the arrows are red to indicate heat being added. If we're going in the other direction and we start back up here where we have the most heat energy and the highest temperature, and we start to lower the temperature and start to cool it off, we are seeing condensation. And that is when the water vapor particles start moving closer and closer together, changing from that water vapor gas into a liquid again. And then we're back to this glass of water right here. If we continue to remove heat and lower our temperature, eventually what's going to happen is this liquid water is going to freeze, and the particles are going to move even closer together until they are solid, like our beginning ice cube down here. Those particles are packed very tightly together, and they're vibrating ever so slightly against each other. Again, looking at the labels of our Y and X axis, that gives us the information we need to know to understand what we are looking at in our diagram here. The arrow pointing up where it says temperature, it's pointing up because as we move up the graph, we are adding temperature. The temperature is getting higher. And across the bottom where it says heat energy, as the temperature goes up, the object is getting hotter. More heat energy is being applied. And the same works for in the opposite direction. As we take that temperature and we lower the temperature, that is causing heat energy to be taken away, and our matter begins to cool off and causes phase changes. Take some time and really look at this graph, this chart. We want to make sure that you understand how to read the information on here. If you are still confused, when we get together for the Zoom, we're going to spend some time here again looking at this picture. And as always, you know how to contact us if you need some more clarity on what you're looking at. Until next week.